Every single one of these mistakes come from missing that one minute.
I don't know. I'd have to re-look back at your work. From here, I can't tell you.
And I multiplied it out, this is not right. Always multiply it out, man. Always multiply it out.
I'm gonna go better than you.
Yeah,
I'm really proud of you. You messed up. What did you do? You put it right over at all.
I don't know.
You never put the yeah, but, I mean, we did really well for that one.
For your last name. Yeah.
Right, Dylan.
I started a while behind, so I thought it wasn't gonna get that.
What's your last name, Dylan? Huh? Yes.
Yeah.
Like Hermes.
I'm so angry. I bet it's like brackets were just friends. Right? I freaking hate that.
Okay.
What?
Like a
Life is so hard.
Sometimes like
Squabble books.
I'll just watch it all off and work until I'm about to go to bed, and then I'm like,
That was
I did not.
I couldn't woke up early.
I had to do homework at home, but like,
So I'll be out for 2 more.
Oh, you think it's 85326H? He's like,
Like, I drove into the library, I was not.
yeah. I don't know their hours, but hours are weird.
yeah, there's one day they're open till 7. And then 2 days ago.
Because the library is open like 9. Jesus likes libraries.
Nelly seems to be
Oh, that one, yeah, okay. Wait, here you say that.
I spent 20 hours on Nelly City.
Is it like
So, yeah.
doing that math too?
Yeah.
Do that.
I'm not on whenever you get back. Okay.
Yeah. Me too.
I'm scared.
How you doing, bud? Mercy.
Today's a bad day.
Mercy. I'm going to be at both of these places.
Okay, just let me know when you want to switch.
Okay. I'm going to start here on the overhead.
It's a horse.
So are we going over the test today?
The beginning of the, I am going to go over that, yes.
I think I already asked that question. I did.
I thought I had my purple pen. Oh well. Must have dropped it when I was fighting off bugs on the way here. Okay. Okay, everyone should have their test back by now. And for those of you who came in a little after me a while ago, I was passing them out in here so you can come get your test up here if you didn't get it already. I'm going to go over the paper part of the test. There are two grades at the top of your test. You'll see there's a minus, and the top number is how much you missed on the paper part, and then there's a minus underneath that. That's the number of points you missed on the online part, and so then the number that is circled there is your grade. So let's just take a minute and look over the graphing part, the paper part that you were supposed to do. So you can pull out your paper. Here it's asking you for A, and each time we did these problems, we asked these questions. A is the coefficient of your leading x to the whatever power. All of our x's have a coefficient of 1, and if I multiply 1 all together, I'm going to get 1, and there's this negative out in front. So -1 should be the answer for A. And then for the degree, remember this is a 2, and then this is a 1 and a 1, so I'm going to ultimately have a degree of 4. And then my end behavior, because I have an even degree, they're going to either both up or both down. And since it's negative, they'll both be down. So, excuse me, it has at least 4 real zeros and 3 turning points. This problem is already factored for us, and so we can look right at it and say what our x-intercepts are. They're going to occur at 1, 2, and -2. So the first one's going to occur at 1, the next one at 2, the next one at -2. The multiplicity of 1 has a power of 1. The multiplicity of 2 has a power of 1. The multiplicity of -2 has a power of 2. Whenever it has a multiplicity of 1, it's going to cross. And whenever it has an even multiplicity, it's going to bounce and go. To find the y-intercept, you let x be 0. So you just go back to the original problem, and wherever you see an x, you put in a 0. Okay, when you do that, you get the number -8. You use these points to sketch. So we want to plot our x-intercept. So that occurred at 1, 0, at 2, 0, and at -2, 0. We know that it's down, down, and I know also at -2 I'm bouncing and going. And I also have a y-intercept at -8. 1, 2, 3, 4, 5, 6, 7, 8. So I'm coming down, through my y-intercept, up, down, and there you go. Sorry, I don't have my purple pen. I lost it on the walk over here. So, any questions about that one? All right, turn it over to the next page. I think most everybody did pretty well on the first one. It was on the second one. If people were making mistakes, this was where it was. This came, I chose these problems directly from either a problem that I did in class for you or one of the problems that I asked y'all to do that day that you were supposed to go back and do. Okay, so all we have to do here is factor to see all the parts. So when I factor the denominator here, I would have 2x minus 1 times x plus 3, and my numerator is x plus 1. Vertical asymptotes come from whatever makes the denominator 0. So you would set each one of those factors equal to 0, and then just solve. So x would be 1/2, or x would be a -3. And you should have written it as x equals 1/2, or x equals a -3, because you're given the equation for the vertical asymptote. Horizontal asymptotes, remember, you just compare the degrees of the numerator and the denominator. And here our denominator degree is larger than the numerator, so our answer is 0. So y equals 0 is my answer. And when you have a horizontal asymptote, you don't have an oblique. The y-intercept is just let x be 0. So everywhere you see an x, everywhere you see an x, you put in a 0. And that's going to give you a negative 1/3. So 0, negative 1/3 is your y-intercept. To find your x-intercept, you let y be 0. So really you're saying, hey, I want my original function to be equal to 0. But remember, when you have a fraction set equal to 0, it just says that can only happen if the numerator is equal to 0. And so this would happen if x is equal to a negative 1. So the only x-intercept we have here is at negative 1, 0. Does the function cross the horizontal or oblique asymptote? This is, remember, where you take your function and you set it equal to the horizontal asymptote, because that's what we had. So you would have x plus 1 over 2x squared plus 5x minus 3, and that's equal to 0. Well, that's what we just solved up here. So my answer is going to be x is equal to a negative 1. So yes, it does cross it, and it crosses it at the point negative 1, 0. So before I turn the paper over, does anybody have any questions about any step here? All right, on the next page, you're still dealing with the same function. It just says draw your number line with the intervals created by the x-intercept and any vertical asymptotes. All right, so we had vertical asymptotes that occurred at negative 3 and 1/2, and we had an x-intercept at negative 1. So we create the intervals here, and then we're going to choose test points. I was even reminding you what to do. So you're going to choose test points in each interval. So I chose a negative 4, a negative 2, a 0, and a 1. Now remember, in class, you could just say, is this positive, is this negative? If you want to get a more accurate picture, actually plug it in and say, what is the y value that I'm going to get? So just to show you, if I plugged in to my function, if I plugged in a negative 4, what I'm going to get is a negative 1/3. So this is going to be negative, and the actual value is a negative 1/3. If I plug in a negative 2, I'm going to get a 1/5. It's going to be a positive value, and it's going to be 1/5. If I plug in a 0, I'm going to get negative 1/3. So it's going to be a negative, and it's going to be a negative 1/3. And if I plug in a 1, I get 1/2, and it's a positive. Okay, so those are the values that I'm going to use to graph. With the graphing part, I ask you to please show your asymptotes, show your intercepts, and then sketch the function. So remember that I had asymptotes at negative 3. So you should draw your asymptote here at negative 3, at 1/2, we also had the horizontal asymptote at 0. So I've got all of my asymptotes drawn. Any intercepts I need to label. So my intercepts were, to remind myself, I had a y-intercept at 0, negative 1/3. And I had an x-intercept at negative 1, 0. And that's also the place where my graph crossed my horizontal asymptote. So if I plot negative 4, negative 1/3, that's going to be down in here. So this part of my graph will do like that. What's happening on each side of this negative 1 is it's above on the left, it's below on the right. So it comes right down here. And then on the right of 1/2, it's positive. And when I plugged in a 1, I got a 1/2. So I'm up here. There you go. Does anybody have any questions about any step there? So that's your paper part. For your online portion, I've reopened that, so you could go in there into your gradebook, click review, and it would tell you which ones you got wrong. You could see what the correct answer is and what you actually chose, okay? You do that. Let me know if you have any questions about anything. The other thing that I have posted in announcements that you can go back and see in Blackboard is in announcements, I made an announcement that said I have reopened all of your homework and your quizzes. You have until the 8th, so November 8th at 11:59 p.m. that you can go back and work on any homework or quizzes that you would like to increase your grade. No excuses and no extensions. I mean, final, right? So you've got till the 8th to make any adjustments that you want to. When you go into My Math Lab, it's still going to show the old due date. But I went in behind that and made it so that it would let you work on it. If you're trying to work on one and it's saying you can't increase your score, shoot me an email. Maybe for some reason that one didn't unlock, but they should have all unlocked. The only other time you may have a problem with that is if you did not do a problem and therefore it replaced it with a 0, sometimes that locks you out. If you have one that's a 0 and it locks you out, just shoot me an email and I'll make sure it gets open. Don't wait till November 8th at 10 o'clock at night because I'm not going to respond to you at 10 o'clock at night. Okay?
Excuse me.
Yes.
Madam Mesquite has a...
The quizzes aren't open yet, or are they gonna get open later, or any
Probably not open till 2 o'clock because I didn't expect anybody to be trying to do that while we were in class yet. So give that a check.
No, I think they checked that on third block today. They checked their announcements at the end of our third block. So some of them stayed after because it was an early release day today. So they stayed in the cafeteria to work on work. So that's why they know that it's not open yet.
Okay, that's great. What I want you to do then is once class is over, if you still can't get into those quizzes, shoot me an email because when I leave here, I'll go right to my office, okay, and double check that. But quizzes should be open for that. If it's because you had a 0 is locking you out, I'll have to go individually into your account to release that for you. Otherwise, you should be able to get in there. I'm trying to think. You should be able to go directly to it, not even have to go to Gradebook. You should be able to go directly to that. And I won't be able to see it because I'm looking in the teacher mode and you're going to be looking in the student mode. So please do double check that and shoot me an email, okay? Because it should be open for you to do that. Okay? Don't forget also another thing is that we have our project. And I've already talked to you about how the project works, but I'm just reminding you that that project is due November 17th. You can work alone or you can work in small groups of 2 or 3, right? It is posted in Blackboard. If you need a printed copy, your facilitator should be able to print that for you. And if anybody here would like a printed copy, I can print it for you, okay, if you do not have access to a printer.
I have a couple students that are finished here at Madam Mesquite. Would you like me to scan those over? They choose to work by themselves, so I didn't know if you want them now or wait until the due date.
Let's wait until the due date. That way I get them all at one time. That'll be better for me.
Okay.
Thank you very much. Thank you. Any other questions? Okay.
How much is the project worth as a grade?
It's worth a quiz grade. It's worth a quiz grade. Also, you know, just heads up, yes, November 9th, the day after all your makeup that you want to work on is due, is the day when you would have to decide, am I dropping or am I staying in class? I know there are a few people that are considering what it is they need to do, so that's another option. Remember that as you do work, it's immediately updated. Blackboard sometimes takes 30 minutes to an hour to pull the grades over from My Math Lab. So if you're like, hey, my grade is higher in My Math Lab, give it 30 minutes to an hour. If it doesn't update, let me know. But it should update within 30 minutes to an hour. Every 30 minutes to an hour, they pull it over. Okay? Any other questions?
Excuse me, this is Plymouth. We can't see anything at the moment.
Okay, she'll work on that for you.
Okay. Are you gonna be at the computer or
I'm gonna be at the smart board.
we can see it now.
Okay, awesome.
Okay. I have a question regarding to the assignment that's due on the 17th.
Yes, yes.
Do we have to create our own problems, or are we assigned to a certain problem?
Can we go back to this so I can show her? Okay. When you go into Blackboard,
Can you see that?
can you see what I've got here?
No.
Okay, let me just tell you this. When you go into Blackboard, in fact, let me just go into Blackboard. Okay, when you go into Blackboard, you see there's my announcements there about your improvements that you can do and announcements about the project. But when you go to find the project, come over here to Content and Assignments, and there it says Project. So can they see my screen that I'm doing now? Okay, so you click Project and then click Project Due. Okay, so the first one there is the one that I've done for you to show how it works. And then you see number 1 is listed there for you. So you'll do each of these. So that'll be number 1 that you do, number 2, number 3, number 4, and number 5. So there are 5 problems to do. So if you're working as a group, you all work together, but you're only going to turn in one project with everybody's name. If 2 or 3 of you work together, you'll do that, and you'll turn in one project with everybody's name on there. But there are 5 problems that you as a group do together. Does that answer your question?
Yes, thank you.
You're welcome. Okay, any other questions? All right, today we're starting section 4.1. And again, please let me know if you try to do any work to improve a score and it won't let you in, okay? Shoot me an email so I can go in and make sure that everything that's supposed to get open, it did what I told it to do. All right, in 4.1, what we're going to be talking about are functions and their inverses. For a function to have an inverse, now what an inverse does is it undoes it. Like tying your shoe would be the function and untying your shoe would be the inverse. Okay, it undoes the function. For a function to have an inverse, it has to be 1-to-1. Now remember, first I've been using this word function, 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 and we learned about a function. For something to be a function, it means whenever I plug in an x, I get 1 y back, right? Remember that? And we did the vertical line test to show that something was a function, okay? Well, now we're going to say I have a function. Is this a 1-to-1 function? Is it a special kind of function? So for a function to be 1-to-1, that means that if I have 2 values that are not equal to each other, then if I plug them into the function, the answers will not be equal to each other. That means if I plug in 2 different x values, I get two different y values. So two different x values will always give me two different y values. If I ever want to show that something's not one-to-one, I can just find two different x values that give me the same y value. That would be a contradiction. Suppose my function is this set of ordered pairs, 1, 4, 2, 5, and 3, 6. So here's my function. It's the set of ordered pairs, 1, 4, 2, 5, and 3, 6. So my first question is it a function? And then I want to know, is it one-to-one? So it's going to be a function if each x has one y. All right, so each x has one y. So 1 goes to 4, 2 goes to 5, 3 goes to 6. Yes, each x. So it is a function. Then the question is it one-to-one? Each x goes to one y, and each y has to go to just one x. So 4 goes to 1, 5 goes to 2, and 6 goes to 3. Right? So that looks like, okay, I'm okay there. So yes, yes. Now suppose my ordered pairs were 1, 4, 2, 4, and 3, 6. I want to know, is it a function? And is it one-to-one? So I need to know, does each x go to one y? When I say each x going to one y, it doesn't mean to a different y. It just can only go to one. It only has one choice. So 1 goes to 4, 2 goes to 4, and 3 goes to 6. Each x individually only went one place. So yes, I'm a function. The question is this function one-to-one? So now each y has to go just to one x. So 4 went to 1. 4 also went to 2. There's a problem. Do you see how that one y did not just go to one x? That one y had two different places to go. So this would not be one-to-one because that y, that 4, was connected to two different x values. Okay? So again, now to call it one-to-one, every x gets to go to one specific y, and that's it. It can't go to two different places. When you're looking at ordered pairs, you can look at it that way, but sometimes, and most of the time, you're not going to be looking at ordered pairs. You're going to be given an equation. And so you're going to look at the equation, and you're going to determine, is this a function, and is it one-to-one? So let's ask ourselves, is f of x, which is equal to the square root of 25 minus x squared, is that one-to-one? So to be one-to-one, it first has to be a function, right? So remember with functions, really you look for fractions, you look for radicals, you look for those kinds of things to tell you if it's a function. But if I plug in an x, it's just going to go to a y. It's not going to shoot off to different places, okay? So it'll correspond fine. But what would happen if I plugged in a positive 2 and a negative 2? What happens right here to that value? It's the same, isn't it? Whether x is a positive 2 or whether x is a negative 2, it's going to spit out the same value. So watch what happens. If I let x be 3, look what's going to happen. I'm going to have the square root of 25 minus 3 squared, which is the square root of 16, which is 4. And if I plug in a negative 3, I'm going to have 25 minus negative 3 squared, which is also the square root of 16, which is 4. In both cases, I came up with the number 4, but I started at 2 different places. In one, I started with a 3, and in the other one, I started with a negative 3. So I have a problem because 2 different x's went to the same y. So this is not 1 to 1. All you have to really do is look at the equation they give you, and if you ever see an x that's raised to an even power, it's not going to be 1 to 1, unless they restrict the domain, and we're going to talk about that a little later. Okay? So, as I said before, when we did is it a function, we used the vertical line test. If we see a picture, a graph of a function, we can use what's called a horizontal line test to see if it's 1 to 1. Okay, so here's our friend, the quadratic. When I graph it, that's a parabola. And the question is, let's just ask ourselves first, is it a function? Yep, because if I do the vertical line test, it only crosses it once. But is it 1 to 1? No, because if I do a horizontal line test, it's going to cross it more than once. So this is not 1 to 1 because it crosses it more than once. Now, just a moment ago, I said, hey, all you have to do is look and see if you have an even power on an x. If you do, you can say that it's not 1 to 1. And then I said, unless they restrict the domain. If this was the same picture, but I restricted the domain so that I only looked at half of the parabola, now is it a function? Yes. And is it 1 to 1? Yes. So this is a function, and it is 1 to 1. Okay, but that's because I restricted what values I was willing to look at. Let's suppose that f of x is equal to 8x plus 5, and g of x is equal to 1/8 x minus 5/8. So I have 2 functions there. Now we're just going to play with the functions first before I start giving vocabulary to it. Let's first find what f of 10 is equal to. That says go to the function f. Wherever you see an x, we're going to put in the number 10. So I plugged 10 in and it spit out 85. Now let's go to the function g and plug in 85. So that means go to the function g and plug in 85. So that's going to give me 85 over 8 minus 5 over 8, which is equal to 80 over 8, which is equal to 10. Do you see how I went in one big circle? I started with 10, I went to 85, I plugged in 85, and I came back to 10. That's what inverses do. They undo what the other one did. So I'm going to tell you, heads up, G is the inverse of F because it undid what F did. See, f took it from 10 to 85. G takes it from 85 back to 10. Okay, so they're inverses of one another. In general, if I do not have the functions, what we say is if I do the composition of two functions, remember doing composition? If I do f composition g, if I put g inside of f and I get x, and if I put g inside of f inside of g and get x, if I do both of them and it just spits out the number x, then g is the inverse of f. And what we say is we say that g of x is equal to f inverse of x. This is the notation for inverse of a function. So let's prove that with the g and the f that I just had at the beginning. All right, so using our previous functions, f of x was 8x plus 5, and g of x is 1/8 x minus 5/8. All right, let's do our compositions and see what it spits out. Okay, so our first one is where we put g inside of f. So here's my f. That means right here is where I'm going to put my function g. Okay, so I'm just going to distribute, and that's going to give me x minus 5 plus 5, and that's going to give me x. So when I put g inside of f, I got x. Now I have to do it both ways because it has to work both ways or it's not true. I can't say that they're inverses of one another. So this time I want to put f inside of g. So I'll have 1/8. And then right here where there's that x, I'm going to put in my f function. 8x plus 5 minus 5/8. So that's going to give me, when I distribute there, I'm going to get 8/8, which is x, plus 5/8 minus 5/8, which is also equal to x. So in both cases, I came up with x when I put one inside of the other. When that happens, then I can say g is the inverse of f. Okay? There are three basic things that you ask yourself. If they just say, hey, I'm giving you this function, is it the inverse of another one? You want to check for three things. So if you have the question, is g the inverse of f? The first thing you have to say, well, is f 1 to 1? Because if f isn't 1 to 1, it can't have an inverse. I don't even have to do any more work, okay? Because it has to be 1 to 1 in order to have an inverse. Number two, this is something we haven't talked about yet. We have to check the domain and range of each of the functions. Because what happens is, since one is undoing the other, the domain of f is actually going to be the range of g. And the range of f is going to become the domain of g. So the domain and range just switch places. Okay, that's what happens. So the domain of f needs to be the range of g. And the range of f becomes the domain of g. And the third thing you would check is what we just did. You're going to do F composition G and G composition F, and you need them both to come out just to be X. Okay? If all three of these work, then it is the inverse of the other. So you would check to make sure F composition G will become X and G composition F will become X. Okay? So if that's true, you're good to go. Now, one thing I want to show you is if you were looking at a graph, and they're going to give you a couple of problems like this in your homework, you're going to look at some graphs, and they're just going to say, okay, I have graphed two functions on this same axis, and I want to be able to decide if these two functions are inverses just by looking at their graph. Well, you see this dotted line that they have right here, this dotted line? That's the line y equals x, all right? So it's at, 1, 1, 2, 2, -1, -1. That's that line. And what you want to do when you look at a graph is you want to be able to fold, think of that as a piece of paper and just fold it right on that line. This side should lay exactly on top of the other side. It should be a reflection of each other on the sides of that line. So you see with this, you've got this part and this part, and if I folded it over, it would look just like that part and that part. See how if it folded over, it would lay right on top of each other? They're a reflection. It's a mirror image along that line. If that's true, then they're inverses of one another. Okay? And that's also true over here on this other side. Here we've got our dotted line, and here's this little loop. It's got a hump and a loop, but this other one, if I folded it over, it would lay right on top of it. So that's what it has to do. I'll show you another picture of that also. Here's another one that you can see. Here, even though they're crossing the dotted line, all you do is you look at the imagery. Here is here and here. This is what's on the left side of that line. And if I folded it over, it would lay right on top of the other side. They're mirror images, so yes, they would be 1 to 1. Okay. So that's what they're asking you to do when you're looking at a graph. All right, so here we have two functions. We have f of x is equal to x cubed minus 1, and g of x is equal to the cube root of x plus 1. And my question is g the inverse of f? That's my question. So we're going to ask ourselves those three questions that we just wrote down in our notes. So number one, is f 1 to 1? Okay, so we look at it. Remember me talking about the exponents that you have? This is an x to the third. Remember, they're not a problem. It's when it was x squared that was a problem. So if you have a odd power, you're going to be fine. Because if I plug in a 1 and I plug in a -1, they're going to spit out two different answers. Okay, so this would be yes. Okay, you could also look at the graph. Remember the graph of x cubed looks like that, so that would be that graph just shifted over, okay, or up or down, depending on what equation you're given. So this is 1 to 1. Yes, I'm good with that. Then the next thing is I have to look at the domains and ranges of my f's and my g's. So for f, the domain for f, think about what can I plug in. There are no restrictions there. There are no radicals. There's no fractions. So my domain is going to be all real numbers for f. And my range will also be the same answer. Okay, there is spitting out positive and negative numbers. Good. So I need to compare that with my domain and range of g. Okay, so looking back, here I've got the cube root of x plus 1. Because it's the cube root, I can take the cube root of both positive and negative numbers. That's not a problem. So there are no restrictions to what I can plug in for x, so all real numbers. I'm also able to spit out both positive and negative numbers. So I still have, in both cases, all real numbers for each of them. So what you want to check is that the domain of f became the range of G, and the range of f became the domain of G. And it does. So my domain and range thing is fine. So that's step 1. Step 2. Step 3, do your composition. So I have to do F composition G, which means put G inside of F. So that means go to the function F, wherever there was an x, which I had x cubed, I have to put this entire function in. So the cube root of x plus 1 minus 1. And that's cubed, right? So what happens when you cube a cube root? That's right, they undo each other. So I have x plus 1 minus 1, which is x. Now, just because it went one way doesn't mean I'm done. I have to do both because there are situations where it works one part and it doesn't work the other. So you can't assume. So the second part I have to do is F composition G, where I'm going to put F inside of G. So go to the function G, which is the cube root of x, and my x is now going to be my F. And so this becomes the cube root of x cubed, which is x. So both cases, F composition G, G composition F, spit out an x. So I'm good. So yes, therefore, G is the inverse of F. And so you could denote G as F inverse of X. One thing that I will tell you about now, and as you go into 172, they're going to stress this again. This notation of having this -1 here, this is not an exponent. That doesn't mean F raised to the -1 power. This is just notation. When that notation is on an F that represents a function, it's just saying this is the inverse. Okay, that's not an exponent at all. Any questions about any step there? All right. Find here F composition G of X. So I'm going to give y'all a minute to do that part on your own. Find F composition G of X. That's where we're putting G inside of F. This is good practice because I know when we did composition, sometimes people weren't sure about what was going on there. Not leaving enough room for my thingy. we go. So when you put G inside of F, then that means in place of that X, I had to put 1/2 X minus 5. So I'm going to distribute my 2. And that would be 2 over 2, which is ultimately going to be 1. And then minus 10. And then I have to add that 5. Do I get just X? No. So that would mean if I was working through this problem and I don't get X, just X, then if the question was, is G the inverse of F, I would say no. Okay, so it has to come down to just being X all by itself. All right. There's still maybe 1 or 2 other problems that I would like to discuss, and I will finish the part of 4.1 on Monday. But go ahead and start working on that homework. Also, please do let me know if those quizzes didn't open up for you, okay? Shoot me an email because I want to fix it for you for the weekend. All right? Okay.